Hello everyone, my name is Andrei and I'm glad to see you all on this session on Winter Data Meetup organized by DataZen and ComDay communities. And today we meet Mark Makary, a tech expert ready to show you how AI can get smarter with real-time data. And we will learn how combining data streaming with RAG makes AI conversations more accurate and relevant. But before we jump into our session, I'd love to take a moment to ask you for your support in growing our community and recognizing our speakers. If you're enjoying today's discussion and want to stay updated of upcoming events, please hit like and subscribe buttons below. And your participation not only acknowledges our efforts, but also helps us reach a wider audience, allowing more people to learn from these insightful discussions. Also, in the video description, you will find a link to the talk page where you can share your feedback, award speaker a badge, and rate this session. Your input is incredibly valuable. It helps us improve future events and ensures our speakers get the recognition they deserve for their hard work. So, we'd love to hear you through the talk. Please ask questions in the chat, and we will be discussing all those questions during Q&A session at the end. And Mark, floor is yours.
Great. Thank you very much, Andre. Good day, good evening. All depends, I guess, on where you are. Thank you very much for taking the time and joining the session today. My name is Mark Makary. I'm a director with the EPAM Data Analytics practice, and I'm leading the EPAM Fast Data Center of Excellence, or COE, which is focusing on the events and data streaming ecosystem. To start, I would like to thank my colleagues at the DataZen community for hosting my talk and for their dedication, all the great value that they add to the community. Thank you very much. I usually like to start with the why, identifying upfront the value beyond our conversation today. The concepts that we are going to talk about today are not new. However, the way those concepts work and the way those concepts work together is relatively new. And as an IT practitioner who has been in the field for a long time and experienced many evolutions, I can tell you that our ability to learn new things and adapt to changes is really much more needed nowadays than any other time. So today we are going to start with understanding the fundamentals of large language models, LLMs, prompt engineering, RAG, event streaming, and then we are going to bring everything together in a pragmatic architecture that brings an elegant solution for an interesting use case. And we are going to take questions after we conclude the presentation. So let's dive in together then. So AI models are just another piece of software that has evaluation rules, has input and output. However, those rules are generated by machine learning and training a base model or a structure on large data sets instead of being handcrafted by humans. I'm going to give you an example. For instance, if you have something like an email spam detection service, one option is to create such a service, is to code by hand, manually coding the rules to detect all the possible variations of anomalies. For instance, by checking various aspects that would help with detection, such as frequent words mentioned in the content, the sender email address, the links, and many more aspects that we usually consider. And we also consider the combination altogether by adding different weights for different factors. As you can see, it's very complex effort, and hand coding in this situation is not an efficient undertaking based on the time and effort spent and the limited outcome. Now, on the other hand, that if we are using machine learning to identify classifications and patterns to build what we call a set of features or characteristics to compare against to detect those anomalies. The machine in this situation would generate for us those evaluation rules. For instance, if we have an email address, domain name has 0 in the middle instead of O, then or letter O, then this is a feature match. As a number in the middle of a domain name is considered the characteristic. This is without really the need to store all the legitimate domain names to compare against or handcraft such a rule. And you can take this and apply this concept to all the other aspects that we talked about that involved in this process. So, we want to make those AI models, take them farther, make them smarter. So we can use, for instance, a string of words, or what we call them tokens, as we use them in natural language processing or NLP model. And we take this input or a string of words as a unified input to identify and retrieve a desired output. Where we can use this technique in something like predictive analytics or Gen AI capabilities and applications. So we had limited progress in that space till 2017. Before that, we really had problems with the cost. It was cost prohibiting to do all this complex processing. And we had limitations on the software and the hardware that is available to us. However, in 2017, it was like a perfect storm, a breakthrough. Google introduced the transformer architecture, and we started to have mature cloud capabilities on the software and the hardware side too. And that helped us to see a viable path forward. Now we can use deep learning and neural networks to build complex large language models or LLMs for really far and beyond, where we can transform an input to a desired output based on the weight or the probability of the next token in a really complex LLM network. And the rest is really recent history. So let's quickly explore some of the use cases that we have for LLM. As you can see, LLM models are serving diverse applications across various industries, utilize them in both predictive AI and Gen AI capacities. For instance, in healthcare, Gen AI can assist us in diagnosis of diseases. The same thing that happens with engineering, with troubleshooting. In finance, we can use it for something like fraud detection, and risk assessment. Also in marketing, we can use dynamic pricing engine to be able to be competitive and beat the competition in terms of the pricing. In education, you can actually create content for learning, media and entertainment. Of course, we can see all this content generation in that space. Logistics, we can use them for something like predictability on the last mile delivery and how be able to save on the carbon footprint in there and the cost, and also on supply chain, we can use it for predictive inventory management to be able to get our components for specific products in inventory on time. So all this, great applications, and as you can see in there. However, LMs are not perfect. Um, we have some challenges in there, and we are going forward to focus on the Gen AI aspect of LLMs, and we'll look into what kind of challenges that we see in there and how can we overcome them. So I picked the items that are really more relevant in terms of challenges to our conversation today. Of course, there are other risks, but we are not going to discuss them in this session. And I picked up accuracy, relevancy, and bias of the model outcomes, for our use case today. So to explain those, I'm going to actually use an example or a use case to build you a clear picture of those issues and make it easier to understand. So I'm based out of Texas in the US, and power stations here are really very important. Texas has large industrial facilities, big land to cover, big population, many factors that involved in there. Imagine you have this use case where you have an engineers using Gen AI model over chatbot to troubleshoot equipment failure in one of those power stations, to quickly identify potential root causes and remedies for an ongoing issues to save time and effort. in troubleshooting. So Texas generally historically hot, really hot, most of the year, hot kind of thing. Training data is usually biased to failure related to the heat. However, in recent years, we have many cold spills during the winter time. Actually, we have one today, winter and spring, and those are usually come with freeze warnings. And an equipment failure could be caused by a frozen pipe or similar cold weather aspects instead of the heat issue. The engineer is troubleshooting during the winter time, and the responses in this case could be actually the response that is receiving could be biased to heat issue. This is based on the historical training data set that we have in hand, and the output would be irrelevant to the current root cause, and this is going to be time wasting and misleading. So as you can see, it's not really good. Now, how can we fix this? Can we really make it better? Let's go and have a look together. So let's look at the GenAI model life cycle and look for areas of improvement and see how can we help with the situation that we just described. So of course, the steps that highlighted here are not comprehensive in terms of the life cycle, but it would get the point across and help us see the overall picture in there. For instance, that we need data ingestion and staging before making it ready for model training, right? And things like that. So in the life cycle that we have front of us, we have the training phase where models learn from extensive data sets, and then we have the adaptation by SMEs that we will look into the outcome, and we try to fine tune for the capabilities for specific tasks or domains. Then we deploy those models for use by various applications. And then we have the serving phase. And during the serving phase, we focus on delivering responses or generating content based on the user interaction. Now, as you can see, once the model is deployed, the engineers utilizing the model can improve the model output during the serving phase. And this is where we are going to focus more on this specific aspect. So we will use prompt engineering and in that serving aspect, and it's the process of designing and refining and optimizing the prompts to elicit the most accurate and relevant and high quality responses from those AI models that we are working with. In essence, we provide model guidance using prompt engineering. In prompt engineering, we have the following components, as you can see in there. We have the role, we have the context, and we have the instructions over the ask. In the power station example that we just talked about, the role is really the maintenance engineer. The ask is to identify the potential set of root causes and remedies, and the context is a relevant input that guides the model, such as the issue that we have in hand, the symptoms, and the involved components, and so forth. So now let's explore how this context is used within prompt engineering to improve the output that, where we have those challenges that we talked about, where there's certain bias because of the heat issues versus the cold issues. And this brings us to, of course, the importance of context as part of prompt engineering. And now then, let's say that the engineer within the input that they would provide the current operating temperature and the freeze conditions in the input context. The model is actually going to shift attention and head in the right direction. Even if there is a bias in the data training side, still the model is going to shift the attention and head into the right direction to produce more accurate and relevant output. And this is, will be one step in coming up with good improvement. So can we actually even make it better? Can we enhance the context further so we can produce more relevant output faster? Let's have a look together. We can actually do that by using a technique called RAG, which stands for Retrieval-Augmented Generation. And by using this technique, We use data retrieval from external data stores. We can augment the input and provide more useful info to the model. Imagine that we can use the current maintenance records, for instance, stored in data stores to guide the model further by pointing to a previous failure that happened before, or an issue that might be related to missing schedule maintenance time slot, or or any of those aspects. And this is definitely going to improve the output, at least the time to produce an accurate output within the conversation. So let's even look further, see that if you can actually improve this even and make it even better. To be able to do this, we are going to look into event streaming aspects. I'm just going to do a quick intro to it, and then we are going to see that how can we even use event streaming or data streaming or real-time events to make this interaction better and make it more relevant and accurate, having a smart conversation. So event streaming really evolved from the traditional event-driven architecture PubSub model in the last few years with significant improvement. So for instance, as differentiators, we have persistence as a first-class citizen, right? So we're using log appending, we are using journal style to improve performance in there, right? Especially with writing to disks or persistence. We have the ability now to do a message replay when a message pull or read that happen, and there is not a destructive operation. You can actually go and consume the message more than once. We added resilience through distributed persistence and replications, using replicas. We have better performance through parallel processing by using partitions and multiple consumers running to consume this message at the same time. We can have elasticity, you can scale up and down. We can have horizontal and vertical expansion within the event streaming facilities that we have in there. We have a true consumer isolation, sorry, that where you would have the broker not looking after the consumers and how far they went with consuming the message and things like that that help us with better performance with the decoupling in there. And with having all those great features, we actually using this event streaming model in supporting modern application architecture paradigms like reactive architecture, where we go and build more responsive, resilient, and elastic applications that even push us further to go into the real-time analytics space or real-time insights, where we use data streaming pipelines. We even can use it in a shift to the left model that where we can improve the quality of the data coming in near real time to replace some of the batch processing that we used to in the past to save on the cost and of the processing and all this great aspects. We even added event streaming governance like schema registry and all this good stuff that we would be able to determine upfront the quality of the data. So all this great stuff that we have in there that in terms of advances on the EDA side or the event-driven architecture and all those great facilities that actually will lead us to even use it more and more use cases and applications. And one of them is LLMs or Gen AI, as we are going to see. And we are going to make things even better with the output that coming from those models. That brings us to the use case that we have in hand. So the anticipated one, so the use case that we have on providing the ability to improve and augment the input context using real-time events is basically a banking chatbot for customer support. And before we start talking about the use case, let's talk a little bit about the why we have them, what's the business value behind the chatbot, so we can appreciate the impact of even having this chatbot not working properly. or not a very good customer conversation can actually lead to a significant money loss or customer loss on the enterprise side. So the value behind it that human interaction is traditionally more expensive than machine interaction. And to reduce the cost, we usually use the chatbots to minimize the number of human interaction and even the time that's spent on the human interaction. Um, Adding to that, we can actually also improve or increase the customer satisfaction. And of course, it depends on the relevancy or the accuracy of the chatbot output, as we are going to see in this example. So within the system that we have, along with this customer service chatbot, we have also a risk management AI model that identify if the customer card is at risk. By analyzing different factors for the transaction was done by this card. For instance, the amount of money, the frequency, the vendor, the time, and the location, among other factors involved in there. And in this use case, that AI risk management AI model that actually locked the card, and now the customer in a panic mode, he cannot use the card anymore. And they are looking for help with the issue. And imagine even that to complicate things further, if the customer is also traveling outside the home country and they are outside the working hours for that home country. And usually, instead of calling someone, it's more convenient for the customer to use the chat. So the customer is using the chatbot to figure out the best course of action. And of course, we all need easy access to our. So the chatbots traditionally has a marketing and upselling bias. And imagine the situation that where the customer is receiving offers or irrelevant information upon their first interaction while they are trying to figure out the solution for their problem. It's really a very bad user experience. You know, the customer is going to ask to talk to human, and the customer will not be happy getting on the conversation with the customer altogether. You know, to start with, plus the burden of receiving all those identity check security questions that we are all familiar with from a live agent. Again, it's really frustrating. So instead of all this negative experience, we should create a system prompt engineering context, the context that we talked about in terms of guiding the model. And that guides the chatbot by providing the right information when the chat starts, including the real-time insights of the locked card and how how this happened or the circumstances around it. So the chatbot or the model start having a relevant conversation with the customer. And the chatbot should actually utilize the timely context to ask a relevant question, and it would leverage the RAG model that we talked about, technique that we talked about to pull in data about the user activity and also the user profile. And this is a proactive approach, enhance security, and provide timely assistance to the client. So now let's go to the architecture part. Let's have a look at the real life architecture and how this is implemented. So this is usually the traditional component in that architecture. We have a chat service in here, and the service focusing on the conversation aspects, including even switching to live agents, right? And then we have the orchestration layer in there that where it's managing the conversation. And we have the deployed model ready to be served, and then the APIs on top of that associated with this that we are going to pull. In this high-level architecture, we separated components in terms of different needs and SLAs based on the boundaries of responsibilities of of each component and the relationship with other components. For instance, the orchestration layer can actually call multiple models or other services and data stores, as you can see in there. So now we want to include real-time aspects, right? So we have event streaming, events coming in through event streaming services. something like Kafka or similar. And then we actually feed a real-time data store for events within a certain time frame that configured or similar. And then in this situation, the orchestration service can actually go and pull the near real-time events and have this constructive conversation in there. So the flow that would work in a way that where the conversation starts with the client, orchestration service that would get the relevant event on the locked card in this situation will start asking the right questions based on guiding the model and the responses that they receive from the model that's really relevant to the situation that happened in hand by retrieving the right artifacts and the right flows and all the things that would have more accurate output and timely output for the client in this situation. And as you can see that in here that we incorporated all the concepts that we talked about. So let's go and recap and summarize and all those aspects that we talked about that early on. So to recap, the combination of large language models, LLMs, with real-time data, RAG, and system prompt engineering holds really immense potential for creating smarter interaction, as you can see, by leveraging the system prompt engineering and real-time data and insights. We can significantly enhance the user experience. Of course, we have other variations of this architecture and other variations of utilizing real-time data to better use of LLMs, even for other applications, such as providing timely data for training, for instance, or have more fresh data for training, or firing even the AI agents like the fraud detection AI agent that we talked about as part of the use case, and we just talked about, and many more. However, I believe this is really a good introduction for the concept. And before I go and share some resources, go and answer the question, I'd like to share some resources with you that maybe help with providing more information. So feel free to connect with me at LinkedIn, ask questions even after the sessions. And also, please visit those communities that we have in there that also partner with DataZen and can also provide really useful insights in that space. And that brings me to the conclusion of it, and we can start taking questions. Thank you very much for listening.
Thank you very much, Mark, for this interesting talk. And we have several questions for Q&A now. So the first one will be it a good idea to test a created chatbot by creating another chatbot that asks questions and validates answers? So chatbot talking to chatbot, is it possible?
Yeah, I mean, there's the fine tuning part of it. That's where we talked about within the life cycle that we still need some human interaction to gauge the quality of the output. Pragmatic experience showing us this is something that we really need right now in terms of training the models. Now, in terms of enhancing the output, then it has to that new model that we are talking about that actually going to to look into the responses. It has to have some kind of guidelines to lead us to another model. It's another model, but still, it's a good idea. I mean, in practical terms, I think that we still really need to continue looking into the ethical aspects and the bias and the accuracy and relevancy as humans first, until we get to a point that where we have higher quality and their output as an output on based on the training side.
Okay, thank you. So we had some examples for such use cases like Go game, right? The LLM was
Exactly.
trained with people first, but when it started training with itself, it reached much better results at the end because of
Yes.
speed of those test cases. So the next question: what cultural or location or personal specifics should be taken into account to create a successful chatbot? For example, young audience or older people audience. So what is important to
Yes, and this is
make?
actually something that it's a very good question, and that goes in the personalization side, right? And that's why we have RAG, for instance, pulling information about the consumer of the model. And right now, we are actually using, like in terms of training, and in terms of the data set, we have to have variation on the data sets that related to um, the factors that you just mentioned in there, or some of it. Now, as a general problem, and I think this is actually one of the major advantage of the AI, like as humans that we have finitely, right? We have limited number of items that we can look into, but AI actually can go into the unlimited space because of uh, or a bigger space because of the computing power that it's using in there. It's like we have combined heads all together. So we can actually use AI to figure out those factors based on the data sets. But the tricky part that depends always on the data that we are using for the training. And that's
Mhm.
the data science aspect with also and the data engineering is try to make sure that we have the right variety of data where we can actually figure out what kind of factor that impacting the conversation. And also the feedback loop that we had on the life cycle, and there it's very important to correct those, to figure out, okay, where is if there's any discrepancy or any disregards for any of those factors, where this came from. Did it come from the data that we ingested? Did it come from the way that we train, and so forth?
Mhm. And probably having this streaming part in the architecture, it allows to perform some persona analysis for the person who is talking to the chat in advance, and then choose right tone and language and so on, right?
Exactly. Uh, yeah, exactly. Thanks, Andre.
Okay, and the next question, can reg be a bottleneck in LLM performance?
Yes. So it's not gonna it's not gonna be a bottleneck in the performance um, of the actual model processing to come up with an output, but in the overall cycle, when we actually retrieve the data first, and then we feed enhance the context, and then we feed that as an output. And what happens in there, um, sometimes RAG actually goes into other models, or goes into a very complex database or data store. That's why we use the vectors data store usually, or real-time data store, like Apache Pheno or similar, where we can actually improve the performance on retrieving the data from those data sets. So it's not the actual LLM processing, but it's the preparation for the data before we build the context.
I see. And what was the latency in this RAG chatbot? So do we have a idea how it influence on the latency with
Uh,
RAG enabled and disabled?
Wait, like I can't speak to specific numbers. Of course, we know them, and actually we worked in a few iterations um, to improve the time within seconds or milliseconds, to make sure that the wait time is less and less on the customer side. But because again, the numbers, because we need to to protect the use cases. But I can tell you it's within the seconds. But it's useful to use a technique in there that where you prep the customer perception. You let them know that what you are doing in there. So the chat service, for instance, spit out stuff like stages, that we are preparing response for you, or searching this, or we're doing that. That helps a lot with the perception on the customer side, that they would feel that you are doing something before you come up with a response for them.
Mm. So seconds or milliseconds sounds good latency. Good enough for chats because
I
when
think
we
so.
chat with humans, it might take minutes before we get any answer. Not
Exactly. I
sure
think
it's correct one.
was the human aspects that having multiple chats running on your screen, if you ever seen those in parallel, feel for them, but yeah, responding to multiple questions at the same time, it takes them forever, I guess, to come back. So
Yeah, and one more question. Are there any effective methods for caching queries or prompts for similar content so as not to rescan documents with reg again and just use the basis of the previous analysis and previous contexts?
yeah, very good question. And that's really the rise of the serving um, facilities on the prompt engineering side, where we don't just prepare smart questions or good context for input, but also keep track of the context. And that's where we do the caching, something like a dial or similar, where you'll be able to keep track of the conversation, and you would have contextual context in there that were, or you would have um, uh, um, the context chained and be able to depend on whatever was discussed within the conversation to improve this conversation and improve the performance of it too. So sometimes that we ask the question in different ways on the prompt side. This is also one way to do it. And this is shared between the regular prompt engineering, that where we would have a prompt and the system also.
I see. Thank you. And one more question we have. Do you think that hackers can provide GenAI with false information to achieve their expected results, even using agents' access to manipulate various systems?
So we have the training part of the model, and once the model is trained on this data and go to the serving, we are not going to retrain them using prompt engineering. It doesn't happen. So it's always going to depend on the context. So if there's something that was exposed during the training, and then you would try to craft something to expose them. This is actually what the hackers do to probe the system to see that if they can spit out features or any data that was picked up um, as part of the training, and expose those data as a data breach. That happens. Now, in terms of actually using agents in there also, that requires more invasive access to the system, that where you'll be able to install those, and then you will be able to fire those to do some harm in there. But again, security, as anything else was in computer science, it's possible to do it. It just depends how much access or how much of an ability that you have with the system that would allow you to get access to do something like that in there.
Yeah, bad actors are always somewhere near us. We should be
Yes, and
ready for
actually,
attacks.
I'm more concerned, instead of hacking the system, is actually using um, the Gen AI capabilities as bad actors. Again, because that unfortunately helps with figuring out stuff that we are not used to, or 0 day, as we call it as humans, that we didn't really anticipate at first. And then it was picked up by the AI instead.
Yeah. Okay, we have no more questions for this session. Mark, thank you once again for this interesting talk and for being our active contributor for all our winter data meetups. And thank you all who joined this session and for being such engaged audience during this session. Please don't forget to say speaker thank you by awarding a badge and rating the talk. And be sure to subscribe to our channels for more content like this. And we hope to see you tomorrow on our next sessions on the Winter Data Meetup. Thank
Thank you
you
very
all. Thank
much.
you, Mark. Bye bye.
video.